Yeah, hello again. Here we are at video 6 of the 4RL series, the DQN agent.gd script. Let's take a look at that. So if you remember, we went from the simple neural network. This is going to call that, and here's where it starts out right there. It says we're going to define a variable. We're going to take one copy of that. We're going to instantiate one copy of that here with the Q network, and we're also going to create something called the target network and do that again. So we've got essentially two copies of that simple neural network we're going to be working with and create a lot of variables. And notice in here we have a new one, batch size. So if you remember, here's batch size shows up again. So if you remember the Q-learning and SARSA both computed what the new value for the Q network should be for that action and state before it left right then. On the other hand, Monte Carlo waited until it was at the end of an episode and then it calculated each of those. Well, this one does something different again. It creates batches, which will happen up in the agent Q-learning GD. And when they get big enough, it'll actually use random samples. Let me get down here to show you. It'll get random samples from within that batch from the replay buffer that's created up in, again, agent Q-learning GD. And it'll use that to actually train the network, quote unquote. So let's go back up here where I was. So here we instantiate the initialize gives me the Q network and target network with the sizes and so on. Update the target network, that's this one right here, and all it does is at this stage for this one it just says make the target network equal to what the weights and biases make the target network equal to the Q network. Okay, then it creates this replay buffer. Okay, and then here's where it chooses the action. This should look very familiar. This is, here's the explore. It says, well, let's take a random action unless the number is small enough. And here it says if the number is small enough, use the Q network forward function. So it goes a simple neural network. It says looks the forward function in there to actually find what the Q values are. So that would be 4 elements there, left, jump left, right, and jump right. And then this one here finds the maximum of it. So this actually is doing the job of finding the best action for that state, exploit under choose action if the random number is small enough. Okay, so I do that. This is a funny and interesting little doodad. So to simple network, the simple neural network uses all arrays to multiply things. So one hot array is essentially, there's two different versions that we're going to be using. One is 1 by 22 and the other one's 1 by 4. For example, the 1 by 22 would have a 1 where the state number would go and everything else would be zeros. And there's another one we're going to use that actually does it the other way. But anyway, that required, the simple neural network requires these vectors, these one hot arrays. And otherwise, our rewards actually typically, it's just a single number, single float. That's what this is working out. Okay, now here's where we actually do the training. So first up, it says if the replay buffer isn't big enough, remember the replay buffer is coming from agent Q-learning GD. If it's not big enough, just go back there and keep on learning. Keep on gathering information. Keep on gathering experiences. Okay, but if it is big enough, let's create a batch. And the batch it does, like I said, is actually a random subset of that replay buffer. And with a random subset, it goes ahead and picks out of each of those experiences, it picks out the 5 values that are in there. And again, these also, these all come from the agent QLearning.gd, which we'll get to in the next video. Okay, then here it calculates what goes into the reward array. Excuse me, it calculates what goes into the target array by using, again, the forward function and the maximum. It calculates what's in what that state is, again, using the forward function for the Q array, and then target Q array, excuse me, and then it finds that error difference between the two, and then it updates first the weights between the hidden and the output layer using that error, and then it calculates the weights and biases, up there, then the weights and biases between the weights, between the input and the hidden layer for the weights and biases. Notice the odd thing there, it does these backwards. It does the hidden to output first, then it does input to hidden second. This is a rudimentary form of what's called back propagation. And finally, after it calculates for that particular element in the batch, it goes and updates epsilon and goes back and does it again. And keeps going until it uses up that batch. Then it goes back and wherever the train was called from, which in fact is agent QLearning.gd, goes back there and keeps on building the replay buffer. And that's it for the EQ agent GD script. It's again very, very straightforward, and that's one of the things I liked about doing it this way. Is what I have is a very simplified form of DQN, and it's simple enough to where you can kind of wrap your head around it. Do take a look at it, please. Again, upload or download the this version of the game, so you've got this code to look at. And I'll call it there. Thank you. Bye.